we have this, again, a symmetric form of a first order differential equation, right, which is essentially equals to 0. So this one is equals to 0. And we have it such that the two coefficients here, these two functions p and q, are both homogeneous. Now this is the homogeneous definition of the lecture notes that I am using to study. So if we write down, this is 1.04 ln and this is 2.2, right? What does this mean? What does this thing mean? It means that P and Q scale in the same way when their arguments, which is the arguments over here, are scaled. So basically this equation, which is P of xy plus Q of xy, does not change under the rescaling that you have if you set x and y rescaled to lambda x and lambda y, which are just constants, non-zero constants. So now what does this mean? Right? So basically what we can do is that we can set lambda equals to 1 over x, right? And why does this work? It works because this equation works for any lambda. So whether you change it to a given value, it still stays the same. These two ratios are the same, so that is why you can set lambda equals to 1 over x. Now if we solve for dy over dx, right, dy over dx will be in this case equals to negative p of xy over q of xy, right? And because these, using this relation that we have over here, we can say p over q of xy is equals to p over q of lambda x lambda y, right? So we set in negative p lambda x and then lambda y over q lambda x lambda y, right? And if we just substitute in lambda equals to 1 over x, right? Now we get that dy over dx will be equals to negative p of essentially 1 and y over x, and then q 1 y over x. This is what you get. Now this can basically be said to be a function of x and y, right? Why is that the case? And we're going to use a relation which defines z to be y over x, and y is a function of x, so z is a function of x. So xz y is equals to y. And this gives us that dy over dx will be equals to z plus x dz over dx. And this is equals to the function that is what in terms of z, because in terms of f of xy, which we define to be f of z. And this results in what? In a separable equation, right? This results in a separable equation. because you can say that x dz over dx is equal to f of z minus z. So now you can say that x over dx will be f of z minus z over dz. So we get that dx over x equals to f of z minus z over dz. And this is the equation that we're gonna use, and we can integrate this, which gets us the result that the integral dz of f of z minus z is equals to ln x plus c. Right, so we have this equation and we have this equation. Okay, that's it.